show that we have to prove this basically. Integration of f of x g of x dx from 0 to a is equal to 2 times of integration of f of x d of x 0 to a. We have been given that f of x is equal to f of a minus x and g of x plus g of a minus x is equal to 4. Now let's look at the proof. So we have the LHS, which is integration of 0 to a f of x g of x dx. What is the obvious thing to do? Yes, make use of this particular property. So we know that integration of 0 to a f of x dx is equal to integration of 0 to a f of a minus x dx. So with this in mind, I have 0 to a f of a minus x into g of a minus x dx, right? Now say this is, let I be equal to this. Okay, we're going to call this as I, and this 2 is I, remember. Now we know that f of a minus x is equal to f of x, that's given. So let's change this expression to f of x into g of a minus x dx. They can look up in given to understand why this happened. So what should I do next? What do you think the next step should be? Yes, adding 1 and 2. So if I add 1 and 2, let me do it here. So we have I plus I, this is 2i, is equal to integration of 0 to a f of x plus, into g of x plus f of x into, let me write in the next line, f of x into g of a minus x dx, right? So here what do we have in common? F of x. So 2i is equal to 0 to a f of x g of x plus g of a minus x dx. But this entire expression is equal to 4, is it not? So 4 times of g 0 to a f of x dx, this is equal to 4. All of this is because it's given. Remember, this is 2i. So 2 1s are 2 2s are. Therefore, I is equal to 2 integration of 0 to a f of x into d of x, which is equal to r RHS, hence proved. So we started off with let LHS be equal to I. So I is equal to this expression and so on and so forth.